So far we discussed the non-accelerating frame, and this time we'll see the case where the observer is also standing on the conveyor belt, but I think I'll do it as a separate one. We'll try to solve the question by looking at the non-accelerating frame. So this was the non-accelerating frame, but the person was on the ground. Now we have the accelerating frame where the person is on the conveyor belt, and the bag as well, both of them are moving together on the conveyor belt. So when you see things from a non-accelerating frame, what this person is observing is the velocity of the bag, which is actually the absolute velocity, or which is practically the velocity of bag with respect to ground, which is velocity of bag minus velocity of ground. But velocity of ground is 0. Why? Because he's on earth, right? So if this is the ground, velocity of ground is 0, and then if you have vb minus 0, which is vb alone, and therefore the term absolute velocity. Or in other words, velocity of bag with respect to the ground is actually velocity of bag. My bad. Is actually velocity of bag as seen directly by the observer on the ground. Whereas when the observer is on the moving conveyor belt, and when he is observing a bag which is also moving on the conveyor belt, now what he sees is velocity of bag. Okay, where is the man standing? On the conveyor belt. Therefore what he sees is velocity of bag with respect to the conveyor belt, or velocity of bag with respect to conveyor belt, which can be written as velocity of bag minus velocity of conveyor belt. Okay, or to be, let me just write it down one more time. This represents velocity of bag as seen by man on the conveyor. Okay, right. Now see, this portion here is very important to understand the inertial frame of the study here. Why? What I've done here, I have analyzed the relative motion of bag with respect to conveyor. So what does it mean? It means that motion of a moving bag with velocity vb, to be more precise, with respect to ground, on a moving escalator with velocity vc with respect to ground, and now we know that this ground is not required, right? Absolute velocity can be expressed as motion of a bag with velocity of bag with respect to conveyor belt on a stationary conveyor. Now look at the changes here. We have two components here, one which is velocity of bag and the other which is velocity of the conveyor belt. Now while we study the relative motion, these two parameters got merged into one, velocity of bag with respect to container, and the escalator which was moving is now considered to be stationary. So velocity of A with respect to B actually implies that it is the velocity of A when you compare C at rest, or when you observe it from a platform at C. Okay, so here we have an observer who is observing bag and the conveyor. Both of them are traveling at velocity vb and vc. Now when you study this in relative motion, motion of a moving bag with velocity vb on a moving escalator velocity vc can be expressed as motion of a bag with velocity b with respect to conveyor on a stationary conveyor. Okay, now the conveyor is not moving, so this element, this vector is missing here. Instead, both of these vectors are compressed as velocity of bag with respect to conveyor. I would repeat it one more time. Velocity of bag and velocity of conveyor. So this method has two components of velocity. Now we have or maybe moving bag and a moving escalator is now put as bag with respect to conveyor on a stationary conveyor. Okay, So this is the difference. So that's why we say relative velocity makes the calculation easier. Why? Because here you have VB, therefore we have AB, we have VC, therefore you have AC, and therefore SB corresponding SC, right? So you will have three equations of motion here for VB and VC. So 3 plus 3 total 6 equations. So the calculation become really complex. Whereas here all you need is one equation by replacing velocity with relative velocity of bag with respect to conveyor. So solving one system using 6 equations versus solving one system using just one equation. That's the difference when it comes to using the concept of relative velocity. Now let's see what happens in this case very specifically with respect to relative velocity. See, when we say we have a relative motion under consideration, the conveyor belt is stationary, which is assumed to be stationary, not actually, which is not stationary. It is apparently stationary. Why? Because the man is also standing on the conveyor. Now the bag is moving with what velocity? It is moving with velocity of bag with respect to conveyor. One more time. What is the bag? What is the velocity of the bag here? The velocity of bag is velocity of bag with respect to conveyor. Now, when this bag is dropped, so initial condition represents when the bag is dropped, and final condition represents when it is apparently at rest. So initial condition when the bag is dropped, velocity of bag with respect to conveyor means velocity of bag with respect to velocity of bag initial minus velocity of conveyor initial. Now what is the velocity of bag initial? We know it is 0. Why? Because it has been, let me just make a note of that here as well. It has been gently placed, right? It has been gently placed, and when it is gently placed the velocity is 0, but velocity of conveyor with initial is 2. Why? Because the conveyor is moving here with a constant velocity 2 meter per second. Therefore velocity of bag convey with respect to conveyor initial would be 0 minus 2 negative 2 meter per second. What does it imply? This implies that the observer who is on the conveyor will feel that the bag is coming towards him with velocity 2 meter per second, because velocity is in the negative direction. So he will feel that the bag is coming near to him with a velocity of 2 meter per second. Okay. Well, that's the primary concept that you will be able to understand here. Now, looking at the final condition. What is the final condition? Velocity of bag with respect to conveyor final will be equal to velocity of bag final minus velocity of conveyor belt final. Velocity of bag final is 2 meter per second, and velocity of conveyor belt final will also be 2 meter per second. Why? Because it is moving with 2 meter per second constant velocity, and therefore 2 minus 2 is equal to 0. Therefore velocity of bag conveyor is 0. What does this mean? It means that observer will now feel that the moving bag has now stopped moving, and that is it has come to rest apparently. Okay, right. So what did we discuss so far? Motion of a bag with relative velocity of bag with respect to conveyor on a stationary conveyor. Okay, now what we'll do is we'll apply the equations of motion in this condition. So we have v square minus u square is equal to 2as. What is v square? vbc. Well, I think I made a mistake here. This is final minus, my bad, this is vbc final minus vbc initial. What is vbc final? We just derived it to be, we found it out to be vbc initial is, sorry, vbc final is 0, vbc initial is minus 2. So 0 minus, this is one place where I see most of the students making a mistake. You know, I would say a really common mistake, because minus 2 square is 4 and 4 into minus is minus 4. Okay, now not plus 4 here, this is minus 4. So minus 4 is equal to 2 into, Since you're using relative motion, every other parameter should be in the relative form, which means acceleration here is also acceleration of block with bag with respect to conveyor, and so is displacement, which is displacement of bag with respect to conveyor. So we have acceleration of block with respect to conveyor and displacement of bag with respect to conveyor. But since this is relative acceleration, in a non-inertial frame, you just can't say that acceleration of block with respect to conveyor is acceleration of block or bag minus acceleration of conveyor. Why? Because this is non-inertial frame, and what comes into picture in a non-inertial frame? The concept of pseudo forces, right? So if we were to understand the concept of non-inertial frame, let us first go through a basic introduction of what is non-inertial frame. While calculating forces in a non-inertial frame, pseudo forces need to be considered, which is meant to be acting on the isolated body whose free body diagram is represented, which means our system here, right? Our system here consists of two bodies, one which is the bag and the other which is the conveyor. And since we are interested in the motion of the bag, while considering the free body diagram of this bag, we will also have to include the pseudo force acting on the bag, whose magnitude is given by negative of mass of the body whose free body diagram is considered into acceleration of the frame. And what is the frame here? The frame in this case is the portion where the man is standing, and the man is standing on the conveyor. Therefore, the conveyor is considered to be the frame, and pseudo force will be calculated using the acceleration of this frame and not the acceleration of the bag. Okay, so if you consider inertial frame and the free body diagram of the bag in the inertial frame, there are only three forces acting on it. Number one, which is the normal reaction. Two, which is the weight of the body acting downwards. And then you have kinetic friction acting towards the right. But when you consider the free body diagram of a bag in the non-inertial frame, you have one, normal reaction, two, corresponding to this, which is weight of the body, three, the kinetic friction acting here as well. But as we discussed in non-inertial frame, we also need to add the pseudo force, and this pseudo force here will be represented as force pseudo or F pseudo, whose magnitude is given by mp into AC, which means mass of the free body diagram, mass of the body which is selected for the free body diagram, which in this case is bag. So this is mass of the bag into acceleration of the frame, which is acceleration of the conveyor. And I have taken, since I have represented this as vector, I have taken only the magnitude, otherwise this would be negative. Okay. Those who are watching it online, I would say you'll have to revisit this at least a couple of times. Write it down on your notes, and then try to explain it yourself, and then you'll understand the concept of pseudo force. So this is really important. Okay, and now if we analyze this free body diagram of the bag, including the pseudo force, we can say that sigma Fy is equal to 0. Why? Because there is no motion in the y direction. Why is there no motion in the y direction? Because the bag is moving on the trolley. So, on the conveyor. If I draw a conveyor here, the bag is moving along the conveyor and not to and fro like this. It is moving along the conveyor. So since it is not moving in the up direction or not is moving downwards, we can say that there is no motion along the y-axis, and therefore sigma Fy will be equal to 0. What does sigma Fy equal to 0 implies? It implies that forces acting upwards should be equal to forces acting downwards, and the forces acting upwards is N. My bad. Forces acting upwards it's N. Forces acting downwards is mg, so N is equal to mg. Now, when we consider sigma fx, what else need to be included here? When we consider sigma fx, as we said earlier, we also need to include the pseudo force. And what is the magnitude of pseudo force? It is mb into AC. Now, there is a mistake in this derivation. Okay, let me give you a minute. Will you be able to find out what the difference is, or what the mistake is? Exactly. The mistake is that the net direction of motion is towards the right. Friction is acting towards the right, which means friction would be taken as positive. Whereas pseudo force is acting towards the left, therefore it has to be taken as negative. So friction here should be taken as positive. So this is positive Fk, positive Fk. Okay. So throughout the derivation, it should be positive Fk, and therefore positive mu k. Now, sigma means sum. There are two forces, one which is positive, other which is negative. So Fk minus F pseudo. What is F pseudo? Mb into AC. Mb into AC. Now, what is the MA here? MA here represent mass of the bag. Let me just write it down one more time. So the mass of the bag into acceleration of the bag with respect to the conveyor. Now let's see. What is Fk? Mu k into N. What is N? Mg. M, mass of the bag into G. Now, throughout this equation, what is common? MB is common. So I can divide this entire equation by MB. So MB will get cancelled. So what we have is plus mu k into G minus AC is equal to acceleration of block with respect to conveyor. Now, what is acceleration of conveyor? See, conveyor is moving with a constant velocity, and therefore the acceleration of conveyor is equal to 0. And since the acceleration of conveyor is equal to 0, this equation summarizes to acceleration of block with respect to conveyor as mu k into G. Okay. And if we apply equations of motion here, this is where we stopped here. Sometime earlier, right? We were trying to derive the relative acceleration. Now we have got the relative acceleration, so you can substitute the formula here, and when you substitute it, what you get? Minus 4 is equal to 2 into mu k into G. Mu k is 0.4, so it is minus 4 is equal to 8 into SBC. So displacement of bag with respect to conveyor is minus half, or otherwise minus 0.5. Okay, so this is displacement of bag with respect to conveyor. So why do we have the negative symbol here? We have the negative symbol here because this is the relative motion. Okay, or maybe let me just write it down here. So displacement of bag with respect to conveyor is equal to displacement of bag minus displacement of conveyor, which is equal to negative 0.5 meter, right? See, if A minus B would give you a negative value, it implies that A minus B is less than 0, or in other words, A is less than B. Similarly, if SB minus SC is minus 0.5, I can write this as SB minus SC is less than 0, right? And therefore SB is less than SC. What does it implies? It implies that displacement by the conveyor is more than that of the bag, and therefore the value is negative here. Okay, that was a pretty long explanation, because it was long because each and every word here is very conceptual and needed explanation. Okay. All right, having said that, let's move on to the next question, which actually is asking you to find the net contact force. Okay.